Hello, this is Mr. Hall, and this is a video on how to do theoretical yield in mole calculations. Sometimes people call it reacting mass calculations. This video forms part of the learning for the IB, so it's good for IB chemists, but if you're part of grade 10 or year 11, you're doing a similar course which involves maths and chemistry, then this might be useful for you too. The IB link that this particularly refers to is to 1.3. And it's called Reacting Masses and Volumes, and the key statement is from the Applications and Skills section, and what it says in it is solution of problems related to reacting quantities, limiting and excess reagents, theoretical, experimental and percentage yields. Now a lot of that isn't going to be covered in this video. The key thing that will be covered is how to calculate this theoretical yield, okay, and that's what we're going to be talking about today. Now theoretical yield is basically the expected amount of product that can be made in a chemical reaction. Now it's likely that in most reactions in the real world you very rarely make what you expect to make because you're going to lose product for lots of different reasons. But it's quite useful for chemists at an industrial level to work out how much they expect to make, and then they can work out how they can maximize their yield to get really close to it. Now as a chemist you can work out how much you could expect to have if you have some key bits of information. One bit of information that you need is your balanced chemical equation. So before we go for any problems, make sure you're up to date and you're good at balancing equations because you'll need that. The other thing as well is knowing what the mass is for one of the reactants, because you're going to do mole calculations with that. So one prerequisite for these calculations is to be able to do mass, mole, MR calculations comfortably. So there's a number of ways of remembering how to do it. The way that I kind of try to remember it is Balmoral, which sounds a bit like Balmoral in Scotland, with the M at the end obviously changed. So Balmoral, the capital being important, stands for balance the equation, that's the bal bit, so you have to balance your equation first. Then you have to do moles from mass, that's the mo bit. Then you've got Ra for ratio of moles, and then finally you've got to do mass from moles. Okay, so that's basically the steps we're going to do. And I'll go for a practice example just so you get a feel of what it's like. So here's a typical problem that chemists might have. So it says calcium hydroxide is made by adding water to calcium oxide. What mass of calcium hydroxide is made from 14.2 grams of calcium oxide? So I always like having a good table, so a table helps me organize my ideas. And my left-hand column, out of the middle and the right, says given, and the one on the right says find out. So this is the column which I use to put in the information for the compound in which I'm given some information, particularly some mass information. And this is the one where I need to find out the mass of the compound. Now if I read the question really carefully, it says what mass of calcium hydroxide is made. So clearly calcium hydroxide is what I'm looking for, so I'm just going to put the formula of that here, and that'll be really important for later on. Now over here is for the mass I've been given. Now I can see I've got 14.2 grams of calcium oxide. So I'm going to put calcium oxide here, which is CaO, and I'm also going to put in the mass, which is 14.2 grams. Okay, now that's great. Now, the first step of what I mentioned earlier was balance the equation. Now, you can see here that the equation actually is already balanced. It's always worth double checking it if you're doing a question in an assessment, but in this case I won't because I know that it's balanced. My next step is moles from mass. Now, I've got my mass here, so now I need to convert it into a mole. Now, before I do that, I need to work out the MR. And I'm just going to do it for this one for now. Using my data booklet, I know that the AR of calcium is, one page, 40.08. So it's going to be, there we go, 40.08 add 16.00, and that gives me 56.08. It's always good to use the precise numbers if you got them. I can now work out the moles. Now moles, if you remember, is mass divided by MR. Alright, so I'm going to get my mass, which is 14.2, and I divide that by my MR, which is 56.08, and that gives me, let's put my calculator, zero point 0.253 ... Okay, it's basically a quarter. Now, my next step is ratio of moles. Now, this is really important. If you look at the equation here, for every 1 mole of calcium oxide, I get 1 mole of calcium hydroxide if it reacts with water. So the old mole ratio is 1 to 1. Because I got 0.253 moles instead of 1 mole, that means that I must also have 0.253 moles made, because it's a one-to-one relationship. Okay. As a result, the moles here is 0.253 ... Okay. I now need to work out the MR, because I'm now going to move to my final step, which is mass from moles. Okay. So the MR for this is, it's going to be calcium times, well, plus 2 lots of this. So it's going to be 40.08 add 16.00 plus 1.01, but there's going to be 2 of those. So that's going to equal, let's put that in now, 40.08 plus 16 plus 16 plus 2.02, and that gives me 74.1. Okay, and now just to finish it off, mass, if you've forgotten, equals MR multiplied by mole. Therefore, I've got 74.1, which is my MR. I multiply it by my moles, which is 0.253 ... and that will equal 18.7 grams. Remember, if you're going to use a table format like this to structure your ideas, always show you're working. Even if you're really confident about what you're doing, always show you're working. It's really, really important. Okay, so that's a really straightforward example. It gets a bit trickier when you have to deal with equations which aren't balanced and when the ratios aren't one-to-one. It's a bit more complicated. For these kind of questions, you have to be comfortable with your ratios. And I'm just going to get a different colour pen just so it's a bit easier for you. So lots of different ratios that you might have to deal with. And you're going to have to be able to scale up and scale down with reasonable comfort. So for example, if I've got a 1:2 ratio and I want to move it from 4 to something, I know that I'm doubling up, so it's going to be a 4:8 ratio. Sometimes you have to really show the working if you're not comfortable with it, but that's okay. If I've got a 1:3 ratio going from something to 15, I need to find the common factor, and the common factor from 3 to 15 is 5. So it has to be a 5:15 ratio. Here's a little bit different when I'm going down. So 64:8 to something to 2. So it's going down by a factor of 4, I believe. So that must be 16 to 2. Right? Because if I go up by 4, it's going to go up for both. So 16 will have to go to 64 if 2 goes to 8. And then finally, I've got 12 to 8 to something to 4. This, I believe, is going to be 6 to 4. Alright? So you just got to be quite comfortable with those ratios, and you might need to practice it before you try some of the harder problems, or just spend a bit more time on it. So here's one more piece of advice I'm going to give you, and it's never involve coefficients in MR calculations. The amount of times I see students do this and they get the question wrong, it's very, very frustrating. Just be very, very careful not to involve them in MR calculations, and I'll show an example of where this can really trip you up. So here's another type of problem. So iron is made when aluminium reacts with iron oxide, and you're given some numbers there and you have to solve the problem. So again, I like having a nice table in order to structure my ideas, and the first thing I need to do is I need to balance the equation. So you can do this the long way if you really, really want. I'm just going to do it quite quickly here. So I can see that I've got 2 irons here and 1 there. So I'm just going to put a 2 over here. All right. I've got 2 aluminiums here. I've got only 1 there, so I need to have a 2 there. My oxygen's 3 and 3, they balance out. So that equation is now balanced. I've done my first step. The next step is now to work out the moles from the masses that I've been given. So let's start filling out the table in order to make this work. So first of all, the formula of what I've been given 640 grams of iron oxide. So this Fe2O3, which is the iron oxide, has to go here. Right? And I'm trying to find out the mass of aluminium, so that's going to go there. So this is a different type of question, because instead of asking for what mass you're going to get, it's asking you what mass do you need. It's the same skill, just kind of doing it back to front. So the mass of iron oxide I've been given is 640 grams. So I'm going to put that there. And remember, to work out moles, it's mass divided by MR. So I need the MR of iron oxide. So iron is, I think it's 55.85. It is. So 55.85 times 2. Put 5 there. So I need 2 of those. And that's added to 3 lots of 16. And it's 0.00. So that's going to equal, let's put this in, so 55.85 times 2 plus 3 lots of 16, which is 48. So the mass of that is 159.70. So to work out the moles, it's mass over mR, so it's 640 divided by that number. And that gives me, divided by 159.70, and that's going to give me pretty much 4 moles, 4.01. Now let's look at the old mole ratio. Now if I look at the equation, for every 1 mole, where am I? For every 1 mole of iron oxide, I need 2 moles of aluminium. So the old ratio is 1 to 2. However, I don't have 1 mole of aluminium, I've got 4.01. So to work out the ratio difference, or the new one, I need to double that because it's a 1 to 2 ratio. So I'm going to times what I did earlier by 2, and it happens to be 8.02. So my new mole is 8.02 moles. Always quite good to show the working there, so you might as well write 4.01 times 2 equals that. That's a good step to show. So I've done my ratio bit, and now I have to work out the mass. To work out the mass, I need the MR, or in this case the AR of aluminium, which I believe is 27. Let's get a nice accurate number. It's 26.98. And again, to work out the mass, it's the MR multiplied by the mole. So it's going to be 26.98 multiplied by 8.02, and that equals 6.98. And that gives me 216.25 grams. And that's done. Okay, so that's a typical kind of question. Here's another type of problem. So I'd like to pause the video now and have a go at this question first. And then once you've had a good go at it, I'll then resume the video and then we'll go for the answer together. Okay, so hopefully you paused the video and had a good go. Let's go for the answer together. So, first thing I need to do is I need to balance the equation. So to balance this equation, let me just get a different colour. I notice that I've got 4 chlorines here, but only 1 here. So my first step is to put a big 4 right there. I've only got 1 sodium, however, here, because now I've added another 4. So I need to put a 4 here, and I think that's now balanced. So, I've done my balancing. I now need to work out my moles. Now I need to fill out all this information first, just to get myself organised. So I've been given 460 grams of sodium. So 460 grams of sodium right there. And I'm trying to work out the mass of titanium chloride, which is TiCl4. So the MR in this case is just sodium. So the mass of sodium is 22.99. Now if you remember earlier, I said don't include the coefficients in that MR calculation. If you look up there, I've got 4Na, but we're going to take into account coefficients well later on when we do old mole ratios. We don't need to take into account here, so don't get tempted to do that. So doing a times by 4 is wrong. Don't do that. So I need to work out the moles, which if you remember from earlier is mass over MR. So it's 460 divided by 22.99, and that gives me 460 over 22.99, and that gives me 20.01. Now let's work out the old mole ratio. I can see that for every 4 moles of sodium, it reacts with 1 mole of titanium chloride. So my ratio now is 4 to 1. But I don't have 4 moles. I've got 20 moles, or 20.01 moles. So the question is, how do I get to the mole count here? Well, to go from 4 to 1, you have to divide by 4. So in this case, I also need to divide that by 4. So dividing by 4, that gives me 5.00, lots of other numbers. Therefore, I need to show that here. So 20.01 divided by 4 gives me 5.00. So now I need to work out my mass. For my mass, I'm multiplying these two numbers together, but I need the MR for titanium chloride. So titanium is 47.87. And to that, I'm adding 4 lots of chlorine, which is 35.45. And that gives me 47.87 plus 35.45 times 4. That's 189.67. So to work out the mass, it's 189.67 multiplied by my MR, which is 5.00, and that gives you 948.35 grams. Okay, and that's your answer. So I hope this has been useful. Best of luck with all your calculations with empirical formulae. And later on in other videos, I'll be showing you how to do percentage yield and also limiting reagent, which is quite tricky. Thank you very much.